Hello everybody, this is Gigi from Kauai Community College. This is a video on transformation, part 5, and we are talking about log functions. Okay, we're graphing log functions. So let's take a look. Suppose you have g of x is equal to 3 multiplied by log base 2 of x plus 4 minus 1. Now, looking at this, we know that the parent graph is going to be log base 2 of x. Okay, so let's go take a look at the parent graph for log base 2 of x. Log is the exponent, right? Log is the exponent. So f of x right here is going to be the exponent that you put on top of the base 2 to get the value x there. So let's start with a nice value, say 2. Okay, log base 2 of 2 is 1, because 1 you put on top of 2, which is 2 to the first power, is 1, right? So log is the exponent. Now let's go to 4. That's a nice number. Log base 2 of 4 is 2, because 2 to the second power is 4. And then the next nice number would be 8. Log base 2 of 8 is 3. The exponent is 3, because 2 to the third power is 8. And if we were to go one more, that would be 16. 16 what? 16 4, because 2 to the fourth power is 16. So you can see that when the x value is moving to the right, the y value is moving up, right? The exponents are moving up. Now let's go smaller than 2. Say 1. Log base 2 of 1 is what exponent? So what exponent do we put on top of 2 to get 1? 0. 2 to the 0 power is 1, right? And then if we were to go to the left of that even, to 0, 2 to the what power give you 0? Nothing. It's undefined, right? So if you think back for a second to exponential functions, we notice in the exponential function it has a horizontal asymptote, right? So here in the log function, it has a vertical asymptote because it's the inverse of the exponent. So the locator point, instead of an exponential 1 0 here, 0 1, it would be 1 0 here, right? 1 0. And then depending on the base, since the base is 2, that's going to go out of 2 up 1, 4 up 2, because we're graphing the output is the exponent, right? Now, what happened if the base wasn't 2? Okay, for example, let's say if we were trying to graph y is equals log base 5 of x. Okay, what's going to stay the same? This point right here, the locator point, because 5 to the 0 power is still 1, right? So log base 5 of 1 is 0. Now, the asymptote is going to stay just right here. What's going to move? The other tracking points. How does it move? By the base 5. So we're talking about base 5 now, so it would be the next nice point would be out 5 up 1. And then the next nice point over would have to be out 25 up 2. And that's how that works for log base 5. And then you would have this graph that looks like this, and it would also go like that, right? Same shape. So that's how the log graph would change if the base changes. You're always going to have the point 1 0 and the vertical asymptote. Okay, so But we are talking about this graph. We're talking about log base 2. So let's focus with log base 2 so we can graph the function g of x that we were given. Okay, so how does it move? Well, it is how does the parent graph move? Let's observe the transformation. Here is again the parent graph. The plus 4 inside is going to go left 4. The minus 1 outside is going to go down 1. And the 3 multiplying outside is going to stretch vertically. So here is the function, and I'm going to show you how we get this graph, right? So locator point 1, 0, since we are not stretching or compressing this horizontally, the 1, 0 is going to stay. Okay, and since we moved over 4, your vertical asymptote now is the line x equals -4, right? We move it left 4. And my new x-axis per se, my new reference x-axis is down 1. So the point 1, 0 really is right here. It's not really is 1, 0. It's 1, 0 at my new x and y axis, right? But that's the point when it got moved. And then how do we graph the other points? Well, since this is base 2, we are going to go out. Normally is out 2, up 1. But since there is a stretch of 3, we are going to have to move up 3 units. So this is my next point, right, on the graph. Normal was to go out 4, up 2. But we are vertically stretching this, so we are going to go out 4. And instead of up 2, we're going to move up 6. Out 4, up 6. Because 2 times 3 is 6, and we're vertically stretching this. So there it is, right? The next point was normally 8, 3. So we are going to go out 8 still, because we are not at all going to stretch or compress horizontally. So the x value, the x length doesn't change. But the y, how does the y change? Instead of 3, it's going to become 3 times 3, which is 9. So out 8, up 9. And there is that point right there. And when we reconnect, we get that blue graph, as you've seen there. Okay, now the other point that we really don't need to draw, but we could plot on there is if this right here, 1/2 -1. So we still go out 1/2 because we're not stretching or compressing. And instead of going down 1, we go down 3. And that is that point right there. This is going to be the log graph for this function. Okay, that is it.